Fuel efficiency is critical, but we also need options other than fossil fuels.
Automobile companies are starting to say, look, we want to sell you the cars you want. Sometimes they'll be big, sometimes they'll be fast, but we're going to power them on something other than petroleum products.
One replacement for petroleum products is biofuels. How to make a biofuel? Plant a seed, add some sunlight, water, and nutrients. As the plant grows, it sequesters carbon dioxide. Harvest the plant and process it to make fuel. Burn the fuel to power a vehicle. CO2 is released. New plants grow and sequester CO2. Cycle continues. Biofuel made from corn, aka ethanol, was all the rage just a few years ago, until two things became apparent. Corn for fuel makes corn for food much more expensive. And because increased U.S. corn production pushed wheat and soy crops into the tropics, causing more deforestation, you find corn ethanol leads to more direct and indirect CO2 emissions than using gasoline in the first place.
Now, I'm somebody that owns ethanol plants in America, corn-based ethanol plants. Corn-based ethanol plants are nowhere near as efficient as sugar-based ethanol plants. For every acre of sugar, you can produce 7 times more fuel than 1 acre of corn.
The big drawback to ethanol is that it can't be refined into diesel, the world's principal transportation fuel. Nor can it make airplane fuel.
Ethanol freezes at 15,000 feet, and therefore it's not a good idea for planes to have ethanol.
We are still in a world that runs on combustion engines. There's over 1 million man-hours of just engineering work in a modern jet engine. That's not going to disappear tomorrow. So something's got to feed those jet engines if we want to continue to move around the world. We're looking for renewable, sustainable methods for doing that.
There's a promising biofuel that uses no food sources, is homegrown, and makes both diesel and airplane fuel.
The algae is very, very efficient at taking in atmospheric CO2 and converting it into a mass that we can use as an energy source. Little green balls, that's the name of the game. If you look at fossil fuels, the bulk of the carbon that we're burning now was algae derived. The beauty is the algae is renewable.
On top of being renewable, a clear advantage over fossil fuels. A pond of algae is highly productive.
If I grow an acre of corn over the course of a year, and I take that piece of land and I plant as many crops as I can in 12 months, the maximum yield that I'll get out of corn from an oil standpoint is about 28 gallons. If I do the same thing with an acre of palm trees for producing palm oil, I'll get somewhere between 600 and 800 gallons. If I scrape that acre of land off, put a shallow pond in it, without any technology, just an open pond, I can get as high as 5,000 gallons of oil.
The promise of algae is tantalizing. Like many new green technologies, it's expensive now, but could become cheaper once pilot projects grow to big-time operations.